Okay, I'm going to do some more difference of two squares videos. I want to remind you that it is not possible for me to have the time to do every video, every homework problem, but that I'm trying to pick some to do that represent different types. And again, you've got all those Algebra 1 videos that I posted for you if you need specific help with certain types. Right now I'm going to focus on difference of two squares videos here. If I'm thinking about, can I factor this as a difference of two squares, this is number 73. Remember, the first thing I always got to do, I got to first check for a GCF. And if I don't check for it, I might think I can't factor this problem, but I really can. If I take a 5 out of both of those, that ends up being 16y squared minus z squared. So actually, this is a difference of two squares problem. I hit it by multiplying through by something. Now, the reason I know this is a difference of two squares problem is I see that inside the parentheses I have two terms. I can rewrite them as perfect squares, and there's a subtraction sign in between them, and all those things have to be true, okay, in order for this to work. And so I'm thinking, okay, let me look at this 16y squared. What could I square to get 16y squared? Well, I could square 4 to get the 16 and y to get the y squared. So let's look over here at z squared. Couldn't I square z to get z squared? So if I want to factor this, I still have to keep up with the 5. It doesn't go disappear somewhere. But that 4y that I have, it's going to go in the first spot here, and the first spot here. And that z that I have here is going to go here, and it's going to go here. And I need 1 plus and 1 minus. It really doesn't matter what order I put them in. But I just factored that problem just very quickly. That's why these are such great problems. They usually go really, really fast for us. Let's do 75 next. Okay, 75 is x to the fourth minus y to the fourth, and one of the reasons I picked this is a lot of times when you factor difference of two squares and they have larger exponents on them, sometimes you can factor them and then you can keep factor them after you get it broken down the first time. Okay, notice this is a difference of two squares because I have two terms that can be written as squares, and there's a subtraction sign in the middle of them. If it was an addition sign, that doesn't factor. Has to be a subtraction sign. Now, x to the fourth, if I think 4 divided by 2, I could have a 2 there. I could square x squared. Remember, 2 times 2 is 4. We've got to remember our exponent properties, or this is not going to go well. For y to the fourth, I could say 4 divided by 2 would be a 2 on that also. If I squared y squared, I'd have y to the fourth. So you can kind of figure out what you need to do by dividing this exponent up here by 2. So now, if I write what I've got here, the x squared here, it goes here and here. The y squared here is going to go here and here, and I need 1 plus and 1 minus. I always put my plus signs first, and the reason I do is because they don't break down further. So I'm going to write this x squared plus y squared. It's not going to break down because it's the sum of two squares, and sum of two squares, they don't break down. But if you notice this other one, x squared minus y squared, let me first rewrite it. I could write this as x squared minus y squared. So it keeps breaking down. I could say, oh, it breaks down because I have an x squared, so I put an x here and an x here. I have a y squared, so I'd put a y here and a y here, and I need 1 plus and 1 minus, and I finally factor that completely. But I have to always kind of keep checking because the whole point of factoring is to get something to as simple of a form as you can get it. So that because what we do with factors usually is we use them to solve equations. We usually take a factor, set it equal to 0, and solve. Here they're using a lot of variables that normally we wouldn't have in our real problems, but this is just good practice for breaking down things. Let's look at 83 next. For 83, we have x plus 7 squared minus 9. 85 is going to be a similar problem. It's just the square is, the parentheses squared is on the second part instead of the first part. So anyway, this is a difference of two squares because realize there's a square on this right here. What am I squaring? I'm squaring x plus 7. So that's the thing that I'm squaring. And then now the 9 can be written as 3 squared. Do you see how I've got something squared minus something else squared? Make sure that I didn't mess this video up here. Okay, so what I'm going to do is I'm going to write two parentheses. And the first thing I squared was this x plus 7. So x plus 7 goes here, and it goes here. I know it looks weird, but that's what we do with it. And then the 3 that we squared goes here, and then it goes here. And then I need 1 plus and 1 minus. Okay, that looks a little weird. We wouldn't leave it that way. We'd say, hey, I can do a little cleanup inside of each of those parentheses. I have x plus 7 plus 3. Well, that parentheses, I don't really even need it here, do I? Because x plus 7 plus 3 would really just be the same thing as x plus 10. And x plus 7 minus 3 would be the same thing as x plus 4, because 7 minus 3 is 4. Oh, we just factored it, and it doesn't look so weird now. Sometimes I'll play games with you like that, writing things kind of weirdly. Since we've got some time, let me look at 81. 81, x to the 4th, y squared, minus x squared, y to the 4th, okay? Remember, first thing we want to do is take out a GCF, and there is one here. Each term has at least an x squared in it, and each term has a y squared in it. So if I factor that GCF out first, and I say, well, what's left? Out of the first term, I had x to the 4th. I took x squared. There'd be an x squared left. I took my y squared out, so nothing else is left. Over here, I took the x squared out. I had y to the 4th. I took y squared out, so I'd have a y squared left. Oh, look at that. This is just x squared y squared. If you think of it, that is x squared minus y squared. So I can use the difference of two squares pattern on it. I can say, write my two parentheses. This x goes here and here. This y goes here and here. And there's a plus and there's a minus, and it is factored. Still have some time, so now I'm going to go back and pick something I think that might be problematic. I'm looking for, and sometimes it's hard to kind of tell which ones are going to give you a hard time. Let's look at 49 maybe. So we did, okay, if we're going to factor this one looks a little weird because of the r's in it. It's actually going to be okay. It might be easy. This problem, if you want to kind of get an idea of how it might be easy to think about this, it almost be like it was like factor 3y squared plus 1y minus 10 or something. It's a similar type problem. Those letters in there are going to get taken care of. If you think about it, for 3r, there's only one way to do 3r squared, 3r times r. For negative 10, I got some options, so I do have to figure these numbers out, but I know when I get done, I'm going to have an x here and an x here. That's where that x squared is going to come out. My middle term will actually have an rx in it. If you look at when I multiply that out, that's where it's going to come from. So the letters here make this look really weird. But really, I'm still going to factor it kind of like it was the problem over to the left. I'm going to put a 1 there because that's the number in front of my x, okay? So we could figure this out pretty easily with guess and check possibly. But what I'm going to do is go ahead and do it the way I was showing y'all in class, because a lot of you seemed interested in that. And it's called factoring by grouping, breaking down the middle term, okay? So when I did it that way, I kind of had that little, I'm trying to multiply. Since this is a harder problem, I'm going to take the coefficient out front and the coefficient, the number at the end, 3 times negative 10. That's my a times c here. Remember where that a and that c came from is I labeled it ax squared plus bx plus c. So 3 times negative 10 is negative 30, okay? And then I'm trying to multiply two numbers to get negative 30, and at the same time they got to add up to that 1 in the middle, the b term. They have to add to 1. Now, I had mentioned there was a way to do this in the calculator. I'm not going to do that here on the video because it's kind of hard to show the calculator. So what numbers multiply to give me negative 30 and add to give me 1? Well, I know 6 and 5 have a difference of 1, so that's probably something to do with 6 times 5. If I want a positive 1, it would have to be 6 minus 5 gives me 1. And if you think about it, positive 6 times negative 5 would multiply to give me negative 30. So what I do is I'm going to write down the first term, 3r squared. Instead of writing 1rx, I'm going to write plus this 6rx. Remember, I'm breaking down my middle term here. So I'm going to keep the variable with it, even though it looks weird here. And then this minus 5 is going to also get stuck with the rx. And then I'm going to keep my last term. Remember, I always keep my first term and my last term. Those stayed the same. All I did was rewrite this 1rx as 6rx minus 5rx, and I used this little factoring tool over here to help me do it, this little diagram. So if you remember what we did next is we grouped things up in pairs of 2. So I'm going to look at this set of numbers, and then I'm going to look over here at this set of numbers together, and I'm going to pull the GCF out of each pair. For the first set of numbers, the GCF of 3r squared plus 6rx, I could pull out a 3 and I could pull out an r. And what I would have left over would be an r, and then if I look at the next 6 divided by 3 would be 2. I took the r out, it would be an x. Okay. Now, when I have a subtraction sign right here, that presents a particular problem. I always want to factor out a negative number when I see a subtraction sign in that spot right there between these two sets of numbers. I'm going to factor out a negative, and I'm actually going to factor out a 5 because they have a 5 in common and they have an x in common. If I don't factor out the negative, this is not going to work well. It's not going to work at all. So go ahead and just know that when there's a negative there, you got to divide out a negative number. All right, if I divide a negative 5x out, a negative divided by negative would give me a positive here. 5 got divided out, x got divided out. All I'd have here is r. And if I have a negative 10x squared, a negative 10 divided by negative 5 is how I could look at it, would be a positive 2, and then x squared divided out of x would be a x. Okay, so that was a little different because of that negative sign there. I wanted to make sure I worked one like that because I know that's a little different than some of the ones we did in class. Now, if you look at it, I have a new GCF. Look at that. Those are both the same. It's a new GCF. These are really two big terms. When you multiply things, it's really one term. So if it's two terms, I can take the r plus 2x out of both terms. I'm going to take it out, and that's my new GCF. And my leftovers out of the first term here would be, take the r plus 2x, I'd have a 3r left. Now on the second set of terms over here, if I took the r plus 2x out, I would have a minus 5x. And it's factored now. This is what it would be when it's factored. R plus 2x times 3r minus 5x. We did this by factoring by grouping and splitting the middle term, but it's a great thing. It makes it so much easier than a lot of times the guess and check problem can turn out to be.